touch a little bit on the supporting frame now. Right guys, some basic principles when you're designing your support frame. First one is, I would always allow approximately 20 millimeters extra when you're looking at designing your cavity. That's to include the thickness of insulation and any air gap that's specified. Okay? Somebody asked me the question that always gets asked at this point. What size of cavity do we have to use? Normally we would say you can go down to a minimum of 20, but then again, depending on the building and how tall the facade is, that will have to increase. It could end up being 100. We had a picture of a job here the other day, where they're actually 420 odd millimeters away. I've seen it, and I made the guess at 400, and I wasn't too far out.
Yeah, I was there.
Yeah, you were there. You've done the mock-up, yeah. But what happens there is, so the cavity can be a lot. Sometimes the bigger the cavity, it gets to a certain stage where it's efficient, and then after that it won't harm the situation, but it won't give you any extra. So if you're doing the 400 cavity like you guys are doing, if that was 300 or 200, you're not gaining any extra. It was done on that particular job because there's these things sticking out from the wall and stuff that the architect wants to hide. So that's fine. So basically, when you're looking at designing up this, or you end up getting caught in this on being on a job site. So if we have a building, which is say 9 meters high, because we don't want to break the fire regs, and we have strip windows here. In theory, would them two have the same size cavity? Would this have a bigger cavity or a smaller cavity, or would this have the big or small cavity? So, in theory, which, if I was to say to you, right, which one would have, okay, so we say big cavity, small cavity. So, if I was to decide, there are your two choices. Okay, Windows, DG'd, Windows, DG'd.
It should be the same.
You think they should be the same? Yeah, so if I said to you, one has to be 20, one has to be 30. So the big is 30 and the small is 20. Okay? The same would be 20 or 30.
Yeah.
Which one?
Doesn't matter.
The bottom one, 30, you think this one should be big? Same height buildings, guys. Do you think the both should be big?
It's the size of the fenestration, the volume of the fenestration.
It's the height. It's the height. It's the height. It's the height. Yeah. I'll explain. You're heading down the right path. Maybe I didn't explain it well enough. This building, the height of cladding or ventilated facade spans between the windows. So it's much shorter. So in theory, you could use a smaller cavity. This one, you have span from ground to floor, much larger. So you would have a larger cavity. Even though in theory, the building is the same size, the same height, the same location, and the same everything. The only difference is the design of the facade. So that's just something to bear in mind when an architect throws up drawings in front of you, okay? All design responsibility is that of the whatever project engineer is on the job. I take it on all larger scale jobs, there's an engineer usually on the job, part of the design team. Yeah? Yeah? And down at the back? Make sure they earn their money. You asked me to set in for rivets. Yeah? What centers? Normally 600, we would say. Okay, I can design it up, I can do it up. But I'll explain the reason why we don't do it. As you've seen, I'm in 45 countries with direct salespeople, and I'm in another 35 countries. Loic is the technical manager for our export departments, and he has to look after about 35 other countries. Every single country, when it comes to working out wind loads and sizes of stuff, have different methods of doing it. Even in Europe, where we're all supposed to be the same, we have Euro codes. But the Eurocodes gives us 3/4 of the calculation, and then when you're in France, you have to go for the extra for France. If you're in Germany, you have to go for the extra. And I can give you the basic parts for the first part of it, so I can give you an approximation for it. But what I would always say is that you get that signed off by the engineer on the project to do that. Yeah? Because there's always a little other calculation in place. For instance, in the south of France, you also have to then look after the seismic stuff on the calculations and things like that, which actually tightens up some of the fixings and stuff like that, okay? So be careful about that. Vertical systems are best. We can do horizontal systems, but there's some extra work in it and bigger cavities. Now, for you guys, the installer guys down the back, the guys who like talking the whole time, be very careful, metal to metal corrosion. Okay. You guys will probably specify it, I'd say, or the guys will specify you use aluminium with aluminium, you can use stainless steel with galvanized steel. The guys who are physically doing it on the job site must understand you're not to be mixing metals together. You cannot have aluminium rivets fixing to galvanized framing systems. Okay? I have seen it all over the place. Oh, there's a box of rivets in the van. Let's bring it out. We can fix away on them. Let's use them up. Okay? Ding ding. Oh, we've had 5 panels fall off the wall. Your problem, not mine. So be very careful with that. Another thing just to raise here, and I got a little bit of a surprise. Is anybody in the room aware of what happens between aluminium and concrete? I've seen a lot of aluminium brackets just fixed onto concrete walls here. I don't know if it's in the industry here or not yet. Usually happens if there's water involved as well, but does anybody know what happens between aluminium and concrete? I'll tell you one thing, they don't love each other. That's for definite, right? Aluminium does not like alkali materials. Concrete, cement-based materials are purely alkali. What can happen is that your aluminium can be started to be pitted and eaten at, particularly if water gets into a system. Now, theoretically speaking, most of the water will drain away down the back of the panels, but a ventilated facade could be classed in some climates as a wet zone. So, in practice, while I'm wearing this up to you, is that if you do have an engineer, an architect that has some knowledge of this, maybe they've worked in the USA or in Europe sometime, that it may become an issue on a job site when you're fixing your framing system. Okay? In Europe, we normally get over it by using these thermal pads. Normally what would happen in structural aluminium framing systems is they might put a little bit of bitumen tape or bitumen paint behind the aluminium, or just paint the back of the bracket. You just want to stop that direct connection between the two. Now please remember that, because after lunch when we're talking about how we fix our systems, we are fixing some of our uncoated raw cement boards to aluminium frames. Okay? But our fixing system deals with this issue. And when it comes to anchoring, use fixing specialists. Who would be the best guys for anchors here for the wall?
UPAT.
UPAT, yeah.
Or Fisher.
Fisher. Yeah, we work a lot with Fisher. Them guys will actually come out if you're doing a refurb, or they'll come out and they'll throw up their machine and they'll give you the pull-out calculations on whatever wall you're doing and recommend an anchor system for you. Yeah? They'll quite happily do that. Make sure you use them to do that. Take the responsibility away from you guys as well, okay? As you see, this is a little bit of an unusual training in the sense that if you listen carefully to what I'm saying, I'm trying to gear most of the conversation about what's going to happen to you guys as installers on the job site, to make life easier and faster for you guys going forward. So this is probably one of the more common systems, which is an angle bracket and T and L rail system, where the T rail is your support at the joints and your L rail is your immediate support. Do you operate on the system here of large and small brackets?
Yeah.
Yes.
Yeah? What do you use the large ones for?
Fixing point.
Fixing point? Everybody understand what that is? And the smaller ones are used for?
Gliding point.
Gliding point. Very good. Top of the class. Your T and L rails, are they usually smooth or ribbed?
The T on the sides is ribbed, in the middle is smooth.
Okay, that's one company makes that one, yeah?
Yeah, and the angles are just
Smooth.
Yeah.
Okay. Any guys do glue fixing? Yes? No? Just double check with the glue supplier which ones you want, which ones they want. Some glue suppliers want ribbed, some glue suppliers want smooth. Just be careful there. For me, it doesn't make too much of a difference. Do you know why they started ribbing them?
Well, they could do.
Hmm? No, they started ribbing them because it's aluminium. Like, don't forget, all of this technology came from our brothers in Central Europe, you know? No, it's only 2 millimeters. Thick, and they just rib it by a half a millimeter or something. No, it's not straight. Do you ever get up in the morning? It hasn't been raining. Never rains here, even though it did the other night, 2 weeks ago. And you go out to your car or on your lawn, and there's this damp patches from overnight condensation. It's called nighttime condensation. It hasn't rained, but you have this damp patch on your car, being metal. What can happen with using aluminium frames, if the boards are tight up against them, is that you get this nighttime condensation on the face of boards. And when you come and look at the job, you're going to see wherever the framing is behind it, because that area of the board is a lot colder than the other areas next to it. Okay, so the thermal thingamajig of our panels is transmitted, but it's the effect of the aluminium behind being many degrees cooler that is transmitting that, and you get that dampness. If you do get a phone call from the client or the owner saying there's something wrong here, the panels, the framing is showing through, I would suggest you delay it and you go visit the job in the afternoon, because once the sun comes up, it's gone. It's only condensation. So that's why it was ribbed in Europe, was to try and cut down on that effect on the panels. It's not just our panels, it happens with HPL, and it happens also with some of the ACM materials as well. And they started ribbing them to break down the direct contact between the boards and stuff, the boards and the frame. Okay, panel layout influences, and this is important for whoever, any of you guys price up the jobs? Yeah? So you're the guys who are heavy on the calculators. This is important for you, this slide. The panel layout influences the number of T&L profiles. Right? If you have a look at this one on a vertical pattern, T, L, T, L, T, L, T, L, T. T, L, 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 T, L, 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 T. You can have the same number of panels here. I could have 8 panels here, 8 panels here. However, the cost of framing this design for the same square meterage of fibre cement, I ain't making any extra money out of it. I still got me 8 panels on this. I get the same square meterage. However, your framing system on this one could be 25–30% more expensive than the framing system on this one. Okay. When you start coming into free patterns or unusual patterns, you could end up going T, 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 T. And all of a sudden, your framing system is twice the price as this one. However, the square meterage of boards are going to be the same. So, okay, keep that in mind. Fixed brackets, top, middle, position. Top. Let me guess, you do a 6 meter rail.
3.4.
Huh? So somebody was telling me lies yesterday, is that what you're saying?
Sorry?
So you're telling me somebody was telling me lies yesterday?
Yeah, the first one was 6 meters.
Yeah, okay, I'm only messing. Only joking, huh? Okay, guys, what rail systems do you use normally? How long rails? 3 meters, 6 meters? No, 6? Be very careful where you position. Where would you position your bracket? Top or middle? The holding bracket. Top? Top. Be very careful. And I'll give you the reason. Especially here where you may have 50-degree changes of temperature. If you're fixing in at the top here, the whole expansion and contraction of that aluminium rail is going to be in one direction only. If we fix here in the middle, you're splitting the movement and the expansion and contraction, so it moves up and it moves down. Okay? So this one is a lot more forgiving than that one. I do understand why this one has to be used, because usually that ties in with a concrete floor or something. Yeah? What happens happening quite regularly at the moment is that people are generally using the size of rail in the sizes of the panel. So if it's a 3 meter panel, you'd use a 3 meter rail. If it's a 2.5 meter panel, you use a 2.5 meter rail. And they're kind of doing it that way at the moment, just to get over this issue here on it. But all I'd say is just make sure your calculations are right for your sliding points in these positions here. Aluminium, fantastic stuff, lightweight, strong, resistant corrosion is great. You can use aluminium or stainless steel rivets, fixings. Profiles are extruded so you can have crazy designs. However, the only real downside is expansion and contraction. Now, we had a big long discussion on it, didn't we, yesterday, JT? Or on 2 days ago. Does everybody understand what happens to aluminium when temperature changes? And does everybody believe, I'm going to sound like a preacher here, does everybody believe that the thing can actually grow and get smaller? So if you put up a 6 meter rail, and when temperature changes by roughly 40 degrees, that 6 meter rail is now 6 millimeters longer. Okay? What happens is the molecules grow in size with heat and energy. And when it gets cold, the molecules reduce in size. So, if we were on something like a 40 degree change in temperature, we're roughly looking at 1 millimeter. If you want to design here, I would suggest you're probably looking at designing around a 60 degree change in temperature. That will cover you from -10 to +50. Okay? And that will give you 9 millimeters of growing in an aluminium rail. Now that's a lot to try and compensate and to be careful with for the future. Okay? So what is dramatically, and this is probably one of the most important slides for us and for you guys, is that wherever your rails are joining and meeting each other, it must have a relationship to the panel. And we would always ask for a 20 millimeter gap here. 10 would suffice. Okay? However, if you guys insist on doing 20, at least you're going to be guaranteed it'll end up 15. Alright? If you insist on it being 10, you'll be lucky if you get 8 or 9, 7, 6, you might even get down to 5, and then you're going to be in trouble. And the reason why this is dramatically important for us as panel manufacturers is that aluminium moves like crazy, like a disco dancer. Our fibre cement doesn't move as much, near as much, maybe 20% as much. So as this thing is moving crazy behind it, we're not growing or getting smaller at the same rate. And the risk is that when this goes up and down crazy, you're going to start cracking our panels and our boards. And I know straight away when the frame has gone belly up on a particular job because of the way the patterns of the cracks on the boards have happened. Okay? So it's vital that the relationship is here between the two. 20 millimeters here, 10 millimeters here is fine. That'll give us a 60 degree change in temperature on a 6 meter rail for us. But at certain times of the year, you actually might see that 10 millimeter joint get a little bit bigger and a little bit smaller. However, never have a panel crossing a break in the metal frame. Galvanized steel, less movement, about half, cheaper. Profiles need to be bent, not as many available. Not as long a life. Now, this is a thing now that we did discuss a little bit previous training. Is normally we'd be looking at something like a 1.5 millimeter down to a 1.1 millimeter section. Okay? I would not be using the 0.8 and the 0.6 sections for external claddings. Okay? And the important point here is stainless steel fixings only. Now, when you're using this galvanized system, even in the thinner gauges, the metal is much harder and tougher. You're going to get harder wearing on your drill bits. You're going to have to use the stainless steel rivets, which are a little bit harder they need a little bit more force, so there's more wear and tear on your rivet guns. Your batteries won't last as long when you're working with galvanized steel compared to the softer aluminium. Galvanized, usually top hats, Omegas, Zs. And generally, I think this is a common requirement, which is something like a 275 gram per meter squared galvanized coating on it. Now, what I will say to you guys is that if you are using galvanized frames, what happens sometimes is, you know, when you drill the hole in the frame for the rivet and you get the little debris and the filings off of it, if they're left in the hole, what can happen is that when it rains, under heavy rain, there can be little drops of moisture around the hole, and then we'll get a phone call. Your panels are rusting. Impossible, there's no metal in them. Well, they're rusting. I have brown streaks running down under every fixing. Can't be the fixing, they're all A2 fixings. Stainless steel A2, you know, it takes a lot for them to rust. No, I'm telling you, there's loads of rust marks under all the fixings. And it's usually the filings that have been left in the hole have got wet and are running down underneath. Okay? Doesn't seem like a big problem. However, how the hell do you get rid of them out of there once the thing is fixed? Yeah? It'll probably cost you 5 times more money to clean out them bits of filings after it's been fixed than fixing the panel in the first place. Drilling out all them rivets, cleaning it out, having to replace all the panels with the rivets. Again, the labour cost will be tremendous on it. Okay? So make sure with galvanized frames, because the galvanizing is only a coating on the outside to protect against rust. As soon as you break that galvanized coating, you're into the bare steel behind it and it'll rust. Now, for the guys who are actually blowing the stuff out, I would strongly suggest you keep your goggles on and your safety glasses, because there is a chance that the stuff may blow back into your eyes. Okay? There's many different framing systems being developed over the world at the moment. Floor-to-floor systems in aluminium, no central supports. Thermoplastic brackets. Energy efficiency is the huge thing. These suspension systems. This is a particular super insulation where they just stick a claw into the insulation, one fixing back, and then you can hang your frame on the claw. Redesigned bracket systems to minimize contact with the walls. Or these suspension systems, which have no frame and everything is just held on the fixings. So you could have your wall and your fixings just pop out here, and you can have your frame out here with the only connection between here and there is the fixings. Okay? Very high tech. They're not here yet. They will be here in a number of years' time, I'd say, when everything develops more. Timber. Would we use timber in South Africa for fixing? Yeah. But what about fixing the panels to, screw fixing the panels to timber battens and stuff? Do you think so? I'll tell you a story. I'll tell you another little Irish story. As we say, a little Irish ditty. When we decided to enter into America with our own sales team and stuff a number of years ago, we sat down, we checked the market, we spoke to loads of people, and at the time we decided to produce all the information and omit everything to do with timber battens. The first size decent job we got was about 1,500 square metres on a penthouse in Boston on top of a university building. And it turned out we got a phone call, how the hell do I use your screws into timber battens? I would say probably it may not be the most commonly used thing, but I still think you may end up having to screw fix onto timber battens. We have everything to do it, we have all the accessories, no problem, no issue. However, the only thing that you have to be careful of is preservative treatment here. I believe you do have termites, longhorn beetles maybe. So the type of timber and the preservative treatment is very important. We've always protected timber with EPDM strips along the face of it. And you can have systems that are adjustable or systems that are actually fixed in place. Okay? I'll give you an example. In France, where Louis is from and stuff, 70% of what we fix is on timber battens. Same way in Scandinavia, purely and simply because in them parts of in the countries What happens is that timber is a very much a traditional building material, and they know how to use it externally, and it lasts a long time. And the types of timber they use, of course, they know all about these things. Other countries would never ever use timber, like Australia, for instance. It's always galvanized in Australia. It's always aluminium in Poland for some reason. So each country has its own tradition of building. Insulation for the cavity space. Mineral wool, stone wool, simple terms, isover, rock wool, and then you have all of these piers and phenolics. Which one would you more commonly use here, do you think?
Glass wool
The glass wool, the isover ones, yeah?
and EPS.
Right. EPS, that's the polystyrene stuff. Okay. Now, the isover one you're using, it is the one for external ventilated systems.
Sorry?
It is the one for external ventilated systems.
EPS?
No, the isover one, the glass wool one. Each company makes one for ventilated facades. They're generally breathable, they're waterproof, and they have some sort of fire resistance except the EPS. And what happens is that they're a lot more, compared to what you normally use internally in partitions, they're a lot more denser, and they're more of a bat, we call them. They're very rigid. And they normally would have a black coating, like these ones, on the outside. Yeah, so you don't see them through the cavity. Which one do you prefer using? EPS or mineral or the wool? Which would you prefer?
Yeah, the wool.
What about you guys? Wool or rigid?
They make a cavity.
You haven't used it yet.
They make a cavity better in South Africa.
Yeah, they make a cavity in South Africa.
With
6 times.
resin floss on both sides.
Yeah. And it's waterproof. What happens is the water doesn't soak in and expand it like it does with standard mineral wools, okay? For me, when I was in my installer days, all the many moons ago and stuff, I always found fitting the mineral wools so much faster and quicker and easier to do. Basically, you just get out, when you're at home, you just steal the bread knife, slit the insulation, slide it over the brackets. Ready to go. It automatically closes up and seals up around it. When you're working on rigid boards, you end up having to cut a hole in them to fit it over the brackets. Then you've got to infill the hole, then you've got to foam tape it and all the rest of it to maintain the integrity of the insulation. However, these do have certain advantages. There's that black one there. These do have certain advantages over the mineral wool, and the mineral wool has certain advantages over these. The big one for this is ease of use and fire. Big time. Yeah? However, I think on these ones you can get away with less fixings. Okay? It's very important they're fixed securely. And also on these ones, the big difference these ones means you need, I think it's 100 millimeters of this and only 60 millimeters of this to give you the same R value. Now, I might be a little bit wrong in the measurements, but the point is that you don't need a thickness of this. So where size of cavities become an issue, you may be forced down the route of the more rigid insulations because you don't have enough space for the insulation. Okay? Fire. Yeah. Fire comes in 2 types for this sort of stuff when you're dealing with the cavity spaces. Right, we have 5 minutes. Fire becomes a big issue. And there's 2 types. We have reaction to fire and we have resistance to fire. The reaction to fire is based around the material and how fast that material spreads the flame over the wall. So if we had our wall here and a fire started here, how fast would that fire jump across that wall and go over there? Fire resistance is how fast that fire will get from this side of the wall to that side of the wall. Okay? For us as a material supplier and a material, reaction to fire is probably the most important for us. And luckily enough, being fibre cement, in Europe, there is 7 or 8 grades, groups, and we are the 2nd highest group. And that's a special group, which means it's virtually, in some countries we're classed as non-combustible, like so Germany and things like that. So what we've also done is we've also done the tests in America and things like that. So each country, we're very, very good in spread of flame and fires. And that's with the standard material. You don't have to order it separately. Resistance is normally something that ends up where stops the fire getting from this side of the wall to that side of the wall. And that includes the complete structure, by the way. So it's the cladding, the cavity, the insulation, the fixing systems, your sheeting board, your framing system, and your plasterboard on the inside. So for that one, it's a systems test. For us, to be honest with you, you really can't count us into this test for the simple fact there's a ventilated cavity space behind it that may have open joints. So the construction of the wall behind it is what you need to concentrate on. Okay? However, we mentioned this earlier on. Promat, our sister company, fire protection specialists, have a number of vertical and horizontal fire barriers in place for ventilated facades that remain open until the temperature in the cavity hits a certain degree due to a fire. Currently, the more modern one is fire material like this. So that usually sits in where the insulation is. And there's our cavity space here. This is the back of the board. So what happens is when a fire happens, that part explodes. It's an intermittent paint pad. So when the fire comes up the cavity space, it hits here, bang, that explodes, seals out the cavity. Becomes an effective horizontal barrier in the cavity. When there is no fire or whatever, it remains open and the ventilation can go up and down. There is another one available for bigger cavities, which is a metal strip with holes in it. And that's the same. It's got intermittent paint on it. It allows ventilation and drainage, and then when the fire happens, it seals up. Okay? So they're available for such constructions.
Sorry, what was that name again?
Promat is the company. Yeah, they're our sister company here, yeah? Promat. Yeah. I can't remember, I think it's RSB is the code for it, but once you talk to someone about it, they should know about it, yeah? The joints on the panels. Okay, what we need to consider is the vertical joint is normally, you have the T-profile behind it. The horizontal joint can be baffled or open. Generally what happens is the ventilated cavity behind, it equalizes the air pressures on the inside and the outside of the board. So any water that does pass through the joint loses its energy and just trickles down the back of the board. The reason why the insulation and everything is waterproof is in high winds, they may get a little splashback going back across the cavity that may hit the insulation. Yeah, but the drying effect of the wind blowing up and down keeps the thing dry as well. Okay. Personally, I would prefer you using the baffles, which you had used on that shopping centre job. Yeah, you know the one out the shopping centre one. Use the little
Plastic.
these things.
Yes.
All right, we do them in aluminium.
It's better in aluminium because where there's no joint and the heat.
Yeah, your plastic ones are doing this. Take note, JT. I have agreement. Better in aluminium. Yeah. All right. These are little baffles that just sit in behind the board so you don't see through the joint, and they do block it off. Quite happy with these to be used. They would deflect and stop, I'd say 99% of the water going through into the cavity space. We can leave the joint open, I don't mind. What I do not see a need for, or any need for, and for you guys, is to put sealants in the cavity space, in the joints, like the old systems. Because first of all, for you guys, you've got the masking tape up around all the joints. You've then got the backing rod. You've then got to fill them. You've then got to trowel them off. You've then got to remove the masking tape. And if you've left the masking tape on too long, you've then got to come and remove all the adhesive off the masking tape that's still stuck to the panel. And in 4 years' time, that sealant, what did you say? You have to redo it. It's changed colour. It looks like a dog's dinner compared to the surface on the panel. Pollution will also start going black. And if you use the wrong sealant, the oils of the sealant will seep into the board and cause all the edges of the board to stain as well. Okay? So if you look at the disadvantages against doing it compared to what you get by doing it, I would always question the architect if the specification comes in for doing it. On the rubber gaskets and the rubber seals, okay, they're going to last until you get your final payment after the defects liability period, which is how long here? 6 months? 6 months defect liability period. It's the normal contract. So 6 months after you get your defects liability payment and you get your money out of the job and you're gone, them gaskets are going to start peeling out and falling out.
Yeah, we put them behind the panel.
Oh, you've put them behind the panel.
We use vinyl. That's also not very nice.
No,
Yes.
I know. All right. Okay. By the way, color. Silver on dark panels doesn't look the best. Okay? Okay. If you're flush, anodized aluminium or powder coated aluminium or whatever, by far looks the best. Black joints look the best everywhere. They form real shadow gaps you don't see through. However, what I would suggest is we used to say you could either tape it or paint it. If you are going to do something, I would prefer painting nowadays. What happens with the tape is that the tape is not lasting with UV light attack. It's cracking and falling out and coming out through the joints after a number of years, and it doesn't look the best. So for you guys, I'd say a bit of, car spray paint or something, be very quick to apply a metal one. What I would suggest though first is that all aluminium, raw aluminium, when it comes out of the factory delivered to site, has an oil on it. Oh, I'm losing juice. Okay, thanks. That all aluminium has an oil on it from the manufacturing process that must be cleaned off if you are going to paint it or tape it. Okay. We normally say 10 millimeters, 8 to 12 is the range. Say 10 millimeters. And this is one of the first things I'm going to say is we changed from 8 to 10 for you guys. Because we're nice people. We want to help you. Using a 10 millimeter joint, our competitors use 6 and 8. But using a 10 millimeter joint makes your life easier as it builds more tolerance into fixing the panels on the wall. Because if you imagine you had a long panel running this way, and on this side you had 9 millimeters, and on this side you had 11 millimeters, it's a lot less noticeable than if you had 7 and 9. Because your eye, there's a bigger percentage difference between the two. The same way when you're looking up the joints, which is what catches our eye first, that 10 millimeters makes it a little bit more tolerance built into the system for you guys when you're fixing it. That if you're a millimeter and a half out, it's a lot less noticeable and will cause you a lot less problems than if you're a millimeter and a half out on an 8 millimeter joint. Okay? It also makes setting out a lot easier. A lot of the time I've seen on architect's drawings to give you the size of the panel. And that panel might be 1586. It's a lot easier adding 10 millimeters for centers of joints to that figure than adding 8 or 12. Yeah? Okay. Nearly finished, then we can have a break. What we would suggest is this, that you never run it through, you cut it back. Still looks better on black. And what happens here is you shouldn't fix these aluminium profiles to the rails, because now you're locking everything in place and you got this on the, you get that on the aluminium as well. So they just stay in there by friction. They don't fall, they don't move. Sorry, they don't fall or they fall out. They do move sideways, however. So what we would always say is that if you are at a corner, a little nick, which we'll show you inside in the training center, with your shears or your tin cutters, and it just bends, the metal will also bend itself back. Put that in beside the rail and that stops it moving sideways. We'll show you inside. However, when you're doing joints, sometimes you have to use baffles, schools and kindergartens. Kindergartens, I think it's for small children. It's an invitation if there's a gap between two panels for little fingers to go in and little fingers not to come out again. On older schools, there's a tendency for cigarettes to go in and cause all sorts of problems in the future if Ant catches fire inside in the cavity space. One thing to bear in mind is open joints and the use of membranes or insulations or breather membranes in the cavity space behind. Irish ditty number 2 today. Extension on Children's Hospital in Dublin. Building out the side, it was a lightweight frame steel building. Put it up using the dark panel you've seen there. The architect insisted on a breather membrane being used in behind, so that was fine. We were supplying a black breather membrane, and quote unquote from the installer who was doing it, I will not beep 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 pay that much for your beep 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 breather membrane, unquote. So he went off and bought his own. What the poor guy didn't realise, because he was looking at how much it was costing, was the one that he did buy was red and the one that we were supplying was black. So here he was, he went off and he built his wall, used the breather membrane, put on the panels, arrived on the site one day when it was finished to collect his money, and went, oh, holy moly, what's happened here? Black panel, red line, black panel, red line, black panel, red line. Because you can see through the cavity. The moral of the story is, be conscious if there's an open jointed system specified of what's happening behind the panel. Yeah? And don't always go for the cheap alternative of option, because it'll cost you twice as much to fix the problem in the future. Cavities. Minimum 20. Increases for higher buildings. We have a certain amount of inlet at the bottom. If you maintain the cavities all the way down, you're going to be safe. And we use a series of ventilated meshes to stop birds and vermin and everything getting in and out of the cavity. Okay? Question you're going to get. And you have some more crazy bugs in this country than I do in mine. You have snakes here, you do, don't you? Oh yeah. You need a St. Patrick, by the way. He arrived in Ireland, stamped his stick a few times on Croagh Patrick, and all the snakes just disappeared. No snakes in Ireland. Actually, no snakes on the ground in Ireland. There's a lot of two-legged snakes in Ireland walking around all right. However, protecting from birds and vermin, that's fine. But you can see everything is grilled. You're going to be asking about, and don't forget we have a 10mm joint. So anything bigger than a 10mm gap, you use protection. Hornets, bees, spiders, whatever. Why don't they live in cavities? Why don't? They do, you're correct. If you ever get a call, somebody complaining about spiders, bees' nests or hornets' nests, whatever in the cavity, you have a much more bigger problem than the poor bees, hornets or spiders. Basically what it means is that the ventilation system is not working. Somebody has blocked it off at the bottom or somebody has blocked it off at the top. Because these critters do not like living in windy, blustery areas where there's winds blowing and things like that. They will happily fly off and find a more sheltered place to set up their nest. So if you find that's happening, first thing you have to check if the ventilation is working or whatever. They could have had, the insulation could have been badly fitted. It could have fallen away from the wall. Now there's a nice calm spot someplace in the cavity where they can build their nests. That's an idea. That's an indication of what can happen if things go wrong. Final slide. The backing wall. So we've gone all the way through the construction. Either masonry, light wheel, steel stud. That doesn't concern me. This is the most important point here, is make sure that it's sealed totally around all windows, openings and doors. This is your weatherproofing background. It's your airtightness background. This is the part of the construction that makes sure the water or anything else doesn't get in or out of the building. So it has to be airtight and it has to be sealed up. Okay? And that, the most dangerous places for that is usually around windows and doors. So guys, thanks very much.